Hi everyone, welcome back to the channel Study with Afia. We are going to work through our AS Chemistry paper 11. It's a multiple choice paper. Okay, so let's get started. Sodium azide is an explosive used to inflate the airbags in cars when they crash. It consists of a positive sodium ions and negative azide ions. Okay, underline the important key points in the question. What are the numbers of electrons in the sodium ion and the azide ions? Okay, as we know that sodium azide is given to you. In this sodium ion is given by Na+1, isn't it? So it formed by losing an electron. So from the atomic number 11, if you lose an electron, so numbers become 10. And the azide ion, which is N3 here, which is N3, in this 3 nitrogen is there, with the proton number of nitrogen will be 7, so 21. So nitrogen is being non-metal, it is always gain an electron, isn't it? So it will gain an electron means it will charges. Therefore, 20 plus 1, its number is going to be 22. So your option is B. Question number 2. The graph shows the variation of the first ionization energy with the proton number for some elements. The letters used are not the actual symbols for the elements. Which treatment above the elements is correct? P and X are in the same period in the periodic table? No, they are in the different period. So you can see here, this belongs to the period 2, this belongs to the period 3, this belongs to the period 4. The general increase from Q to X is due to the increasing atomic radius. No, the small decrease from R to S is due to decreased shielding. The small decrease from U to V is due to the repulsion between the paired electrons. So absolutely right. So your option should be D. And what is the reason between them? See, if you look at this, Q belongs to the first group, then second, third, fourth group, fifth group, and sixth group. Okay. Now, if you take element from the group 5, you can choose a nitrogen. Okay, any element you can choose. I'm going to choose for the nitrogen with the proton number 7, right? So how you are going to write it? 1s2, 2s2, and 2p3. And if you're writing them in electrons, so it will be 1 here and 1 here and 1 here, right? And look at for the group 6, oxygen is the example. So with atomic number 8, and you can write them as 1s2, 2s2, and 2p4, isn't it? Therefore, your electrons placement will be 1, paired electrons will be 2 and 3 and 4. Fourth electron will be over here. So you can see that there's a slight repulsion between the paired electrons between the group. So best option is the small decrease from U to V is due to the repulsion between the paired electrons. Okay, so that will be the best describing the question. Aluminium carbide reacts readily with aqueous sodium hydroxide. The two products of the reactions are sodium aluminium oxide and hydrocarbon. Water molecules are also involved as reactants. What is the formula of the hydrocarbon? Okay, let's write the balanced equation. Then we automatically get to know which hydrocarbon it is. So when aluminium carbide, okay, when aluminium carbide reacts with the aqueous sodium hydroxide, water is added with the sodium hydroxide. It means, so aqueous sodium hydroxide, you're going to form sodium aluminium oxide along with some hydrocarbon. And I know that in a hydrocarbon, you will have carbon and hydrogen only. Well, so here I'm having 4 aluminium in the left side. So I need to have 4 aluminium in the right side as well. So when I multiply by 4 to this number, so sodium has to be multiplied by 4 also. So, so I'm having 4 hydrogen here. So when I multiplied by 4 to the 8 oxygen here, right? So this is aluminum. So here we have 8 oxygen. So I need to multiply by here 4 because I already have 4 oxygen in this side. So overall, when you do that, I'm having 4 hydrogen plus 8 hydrogen. Look at this. This is 8 hydrogen and this is 4 hydrogen, makes 12 hydrogen here. And the carbon is 3 carbon. You can only see the carbon over here. Or you can write this as 3 common CH4, right? So your best option will be A. A sample of 35.6, this is your mass of a hydrated sodium carbonate. This is hydrated sodium carbonate, contains 25.84% of sodium ions by mass. When this sample is heated and hydrous sodium carbonate and the water are formed, which mass of water is given off? Okay, let's do the question number 4, explanation over here. So it was hydrated sodium carbonate, isn't it? Hydrated sodium carbonate. So in that sodium carbonate, you're having 25.84% of sodium ions, isn't it? So sodium ions, therefore, the sodium ions, number of moles of sodium ions is going to be mass by mR, isn't it? So if I wanted to find the mass of this, I'm having 25.84% of 35.6%. This is for the sodium ion. Okay, so which will give you around so 25.84 divided by 100, because it is the 0.84 divided by 100 times 35.6. So which is going to be 9.2 grams. Okay, 9.2 grams. So here 9.2 grams divided by sodium. So sodium MR value is going to be 23. So its mass number is going to be 0.4 moles. This is for the sodium. Okay. So similarly, we need to find for the mass of the carbonate ion. So for that, we will find the number of carbonate moles for the carbonate ions first, because we know that for every 2 sodium, there is 1 carbonate, isn't it? So for every sodium, there is 1 carbonate. Therefore, I have to do the molar ratio here. So sodium and carbonate. So here 2 and 1, isn't it? So if you have carbonate as 1, so I have to divide by 2, which is going to be 0.2. Therefore, the mass of carbonate ion, which is going to be carbonate ion is going to be, which is going to be, what is the formula of the mass, number of moles into MR, right? So it will be, you remember the formulas, right? N is equal to mass by MR. N is equal to mass by MR. Therefore, N into MR. Therefore, N is 0.2 into carbonate ion. Carbonate means your carbon is 12 plus 3 times oxygen. 3 times oxygen is 3 times 16. So just multiply 0.2 into 12 plus 3 times 16, which is going to be 12 grams. Okay. Therefore, from 35.6 grams, if you subtract 12 grams and 9.2 grams, you're going to get the mass of water. Mass of water. So 35.6 minus 12 minus 9.2 will be 14.4 grams. So your option, good option is going to be C. I hope you clear it. Solid aluminium chloride sublimes at 178 degrees Celsius, which substrate best represents the species in the vapor at this temperature. Okay. So if you look at this, aluminium chloride with the aluminium chloride will form Al2Cl3, Cl6, sorry. So you can see that aluminium is the charge is plus 3. Aluminium charge is plus 3 and the Cl is minus 1. So when aluminium makes 1, 2, 3 bond, and this aluminium will make 1, 2, 3 bond. So here, this is the strong dipole. It's a dative bond it is forming, right? So chlorine will have a lone pair of electron. This lone pair of electron from the chlorine, it will given to the aluminium. So from here also, this will given to the aluminium to form this extra dative bond, okay? To form this extra dative bond. So an electron should go from chlorine to the aluminium, not from the aluminium to the chlorine. So best describes option A. Whereas in the B, you can see aluminium to the chlorine is flowing. No, whereas aluminium is completely occupied by the 3 bonds, dative bonds over here. And C and D is completely wrong. Now, question number 6. Well, the question number 6, a shape of H3O and the shape of sulfur chloride. So actually this H3O plus, so how it formed actually, when the water reacts with the H plus ion, this will make H3O plus. So how actually it formed? Actually, oxygen has 6 lone pair of electrons. In that, 2 of them will be 1 or 2 of them will be gone to the hydrogen. So here it has 1 of them will be move it to the hydrogen. So it will make a H3O. Still, it has 2 electrons left. So it is forming what? Pyramidal shape. Okay, pyramidal shape. So A. And coming to the sulfur chloride, if you form a sulfur chloride, so it formed a chlorine here and chlorine here. So it has 6 electrons, isn't it? So 2 of them over here and 2 of them over here. It left with the 2 lone pair of electrons, and it should be non-linear. Okay, it's not a linear, it's non-linear. The question number 7, when an evacuated tube of volume 400 cm cube is filled with the gas at 300 Kelvin and 101 kilopascal, the mass of the tube increases by 0.65 grams. Assume the gas behaves as an ideal gas. What is the identity of the gas? Okay. So here, in order to find the identity of the gas, so we need to find the MR value. So from the periodic table, looking at the MR value, we can identify which gas it is, right? And they said it is an ideal gas. And if you go to the last page, you can find all the formulas related to this. Okay, so I'm going to pick up the formula from here, which is given. So look at this formula. So ideal molar gas constant R value is given 8.31 joule per Kelvin per mole. And the formula is, the formula list is also there. Okay. So going back to the question number 7, your formula is going to be PV is equal to nRT, or I can write N as mass by MR into R into T, and here PV, or MR if I make a subject, it will be mass into R into T whole divided by P into V, right? So what is the mass given here? 0.65 grams. 0.65 grams, and the R value is 8.31 and the T is 300. So whole divided by the P value was 101 kilopascal into 1000 because it was in kilo, and then the V is 400 cm cube, but I have to convert them into the meter cube. They are in a standard form, so I have to multiply by centimeter cube to meter cube. You have to multiply it by, let me see. So you have to multiply by, so you have to multiply by 10 to the power minus 6, okay? Centimeter cube to meter cube, you have to divide by 10 to the power minus 6. So meter cube to the centimeter cube. So it will become multiply by 10 to the, divide by 10 to the power 6, or multiply by 10 to the power minus 6. So you will get your option as 40 grams, okay? So in the periodic table, if you check for the 40 grams, and the option should be A. Nitrogen and carbon dioxide, carbon monoxide, both have a MR value of 28. The boiling point of N2 is 77 K and the boiling point of CO is 82 K. What could be responsible for this difference in boiling points? CO molecules have a permanent dipole and N2 molecules are not polar. Absolutely. So the option A should be correct. So CO molecules have a permanent dipole. So how do we know that? So carbonyl also we can say CO molecules. So they and oxygen. Since the oxygen is in the 6th group and the carbon is in the 4th group, so this is more electronegative and this is electropositive, right? So this is more electronegative than the carbon. So it has a permanent dipole. With respect to the nitrogen, since they both are they are equal polarity, right? They have both have equal electronegative in between them, equal polarity. So we can just opt for the option A. Next question number 9. Which statement about enthalpy change is correct? Enthalpy changes of a reaction are always negative? No, sometimes it will come positive also. Enthalpy change of combustion are always positive? No, it is always negative. Enthalpy change of formation are always positive? No, it could be negative. Enthalpy change of neutralization, yes, neutralization are always negative. Yes, it is always negative because in neutralization, what happens? The proton reacts with the hydroxide ion to form a water, right? So it is always forming. So bond is formed here, right? The bond is formed. So the bond is formed is nothing but option D. What is the definition of standard enthalpy change of neutralization? Standard enthalpy change of neutralization. When 1 mole of an aqueous acid is neutralized by an aqueous alkali, or what is the definition of a standard enthalpy change of neutralization, right? So the option should be here D, because this is when an aqueous acid and an alkali react together to produce 1 mole of water. Neutralization is always you need to form 1 mole of water, isn't it? So that makes acid with the alkali to form a water. So that is a neutralization. Hydrogen monochloride is the molecule that kills bacteria when chlorine is added to the water. The following reaction produces this molecule. Which statement about this reaction is correct? Okay, so we need to check to say the first option is correct or not. Let's write the oxidation numbers. Chlorine is a compound molecule, so its oxidation state is going to be 0. So this is also 0. So over here, hydrogen is +1, oxygen. So here the chlorine is going to be +1, and here this is going to be +1, right? And here the chlorine charge is going to be -1. So the chlorine is being changed from 0 to +1. So increase in oxidation states, right? Increase in oxidation number will be your oxidation, and the chlorine again has been decreased also here. So decrease in oxidation number will be reduction. will be reduction. Okay. Therefore, the first option is the correct one. You can see increase also there, decrease also there. So it is purely redox reaction. Nitrogen dioxide exists in equilibrium with the dinitrogen peroxide and O4. Okay. Which condition give the greatest percentage of N2O4 at equilibrium? Okay. So here if you see there are two number of moles and here one number of moles. As we know that high pressure will always favor the side with the less number of molecules, right? With the less number of molecules. So equilibrium will shift to the right side with the high pressure. So we are able to gain a more percentage of the N2O4 in the right side. So its pressure should be high. And if you say that temperature, so the temperature should be low because it is exothermic, right? And if I decrease the temperature and it's being exothermic, the equilibrium will shift from left to right side. That will also help to gain the more. So overall, to have the more percentage in the right hand side and a more yield, for a more yield, option B, like you should have a high pressure and a low temperature. Should have a high pressure and the low temperature. Okay, so when an equimolar mixture of hydrogen and iodine react, the mole fraction of hydrogen iodide in the final mixture is X. What is the equilibrium constant Kp for the reaction? Okay, so we do have the formula. Equilibrium constant is the pressure of the product divided by the partial pressure of the reactants, right? Partial pressure of the reactants. And then we need to write the formula when hydrogen and iodine, their reversible reaction, they form 2 hydrogen iodide, isn't it? And we need to make a IC table here. So here initial changes, initial moles will be here 1, 1 and here 0. And in the equilibrium, it will be 1 minus x, 1 minus x and here 2x. Therefore, total mole is going to be, so total mole is going to be 1 minus x plus 1 minus x plus 2x. So which is going to be 2. Okay, so we need to find the partial pressure for each one of them. Therefore, partial pressure of I2 or partial pressure of H2 will be, which is 1 minus x partial pressure divided by the total mole into the total pressure. Okay, so 1 minus x over 2 into P, or if you're checking it out for the HI for the product, it will be x square divided by 1 minus x by 2 whole square into P, right? So if you look at this formula and we are going to substitute for this, so the HI will be x square and denominator we are having 1 minus x by 2, it's a whole square. And if you simplify this 2 square, will go to the numerator. So 4x square divided by 1 minus x square. So here I just have to write for the here x square will be enough. So your best option will be C. So question number 14. In reaction 1, a student measures the initial rate of production carbon dioxide when copper carbonate is added to 50 cm cube of 0.1 molar dm cube of nitric acid. In reaction 2, student repeats the same experiment using 50 cm cube, but this time 0.5 mole per dm cube of nitric acid and the same mass of copper carbonate. In 1 and 2, acid is in excess and samples of the same copper carbonate powder are used. So which row is correct? So if you look at the reaction 1 and the reaction 2, the reaction 2 is faster, isn't it? Because it is it's using more concentration. So if your reaction 1 is faster than the reaction 2 is faster than the reaction 1 because it uses more concentration. So concentration directly proportional to the rate of reaction. Okay, so I would like to say that if you're taking a ratio of 1:2, where 2 is bigger than 1, so it should come less than 1, right? So this should be correct. Initial number of effective collisions in the reaction 1 per second. Initial number of effective collisions in reaction 2 per second. So once again, number of collisions will be more for high concentration. So higher the concentration, more the collision. More the collision. Therefore, the option should be the forward question number 2. The forward reaction of a reversible reaction is exothermic and has an activation energy of plus 30 kJ per mole. The reverse reaction proceeds by a mechanism that is the exact reverse of the mechanism of the forward reaction. Which statement about the activation energy of the reverse reaction is correct? Activation energy. So, in order to solve this, okay, so How to solve this? Let's draw the exothermic and endothermic situations diagram. So over here, and if the product is here and the reactant is here, so this part is your activation energy, right? So this is my activation energy, and this is my delta H. And over here, this is the product and reactant. This is my exothermic, and this is my endothermic reaction. And this whole thing is going to be your activation energy. And this is the delta H. So activation energy of the reverse reaction is equal to minus 30 kilojoule per mole. So forward reaction of the reverse reaction is exothermic, they said, and has an activation energy of that. So here, this activation energy is going to be plus 30 kilojoule per mole. Reverse reaction proceeds by the mechanism that is exact reverse of the mechanism of the forward reaction. So activation energy for the reverse reaction is greater than 0 kilojoule per mole, but less than 30 kilojoule per mole. It cannot be less than 30 kilojoule per mole. As you can see here, this whole part is activation energy. So the B is wrong. A is wrong. See, activation energy for the reverse reaction is equal to 30. No. So the option should be D, which should be reverse reaction is greater than 30. As you can see, the gap. This is the endothermic reaction, which is the reverse of the exothermic reaction. This is the complete EA, and this part is EA, which is equal to 30 kilojoule. So this EA must be greater than 30 kilojoule per mole.